Hi GOH, this is Unit 6, Lesson 2, and today we're going to talk about what makes a parallelogram. So you should feel comfortable now with the definition of a parallelogram, and that's both opposite sides are parallel, and the properties. So properties are the opposite sides are congruent, the opposite angles are congruent, the diagonals bisect each other. That's something we proved 2 different ways in the last chapter, but let's make a list of all these properties so you have them all in one place. So definition is it's a quadrilateral with both opposite sides parallel. A quadrilateral with both opposite sides parallel. And the properties are both opposite sides are parallel. That's just the definition. Opposite sides are congruent. So there's 2 things about the sides you should know. The opposite sides are parallel and the opposite sides are congruent. The opposite angles are congruent. And the diagonals bisect each other. And I should have left room for one more, so I'm going to add that on, and that is consecutive angles. And consecutive angles means the angles that are next to each other. Consecutive angles are supplementary, and that's something that we also wrote down in that last chapter also, in that last lesson, because they are same side interior angle. Okay? Even though the definition of a parallelogram only involves both pairs of opposite sides being parallel, we can prove that a figure is a parallelogram using other conditions if they are sufficient enough. All right, so given quadrilateral EFGH below has opposite sides that are congruent, fill in the reasons below in order to prove that EFGH must be a parallelogram. All right, so this is sort of backwards. I don't know it's a parallelogram yet. I'm trying to prove it's a parallelogram. I know that both opposite sides are congruent. Is that enough to make sure that it's a parallelogram? We're going to see in a second it is. So EF is congruent to HG. So that's this top side right here is congruent to the bottom. And EH, the left side, is congruent to the right side. That is all in the given. They share HF. All right, HF is congruent to HF. That's the reflexive property. The triangles are congruent. Triangle EFH is congruent to GHF, and that's side, side, side. Once the triangles are congruent, that makes all the corresponding parts congruent. So angle 1 would be congruent to angle 2, and angle 3 would be congruent to angle 4 by CPCTC. Now, if those angles are congruent to each other, then that makes EF parallel to HG and EH parallel to FG. Why? Because those are alternate interior angles. So if the alternate interior angles are congruent, then the lines are parallel. EFGH is a parallelogram because I just showed that those opposite sides are parallel, so definition parallelogram. So this is important. Showing that both opposite pairs of sides are congruent is enough to show that it is a parallelogram. All right, so if I know that both opposite sides are parallel, it's a parallelogram. If both opposite sides are congruent, it's a parallelogram. Exercise 3, that we have lines RU and ST, which are the same length and they're parallel. Using a straight edge, draw in RS and UT. All right, so I'm going to connect R to S, and I'm going to connect U to T. Is quadrilateral RSTU a parallelogram? How can you tell? Well, if I take out a ruler and I measure these, okay, this was 3 inches, and this was 3 inches. And they already told me in the beginning that these sides were congruent, and now I know the top and the bottom are congruent. So is it a parallelogram? Yes, because RS is congruent to UT. So both opposite sides are congruent, therefore it's a parallelogram. Oop, that should say it's. So RSTU is parallelogram. Okay, but think about what I started with. All I started with was that, I'm going to do it in green, this left side and this right side were both congruent and they were parallel, and yet that made it a parallelogram. We're going to list all these ways tomorrow as well in the beginning of class, just so you have them all. Okay? All right. So exercise 3, which we just did, implies that a quadrilateral with one set of equal parallel sides must be a parallelogram. We're going to actually prove that right here. So in this diagram, it's known that RU is congruent to ST, and RU is I should have done parallel first. So RU is parallel to ST and RU is equal to ST, and they want me to prove it's a parallelogram. So that's going to be my given. My given is that RU is parallel to ST and RU is congruent to ST. And that's given. All right, let's put in some numbers right here. If the lines are parallel, then that makes angle 1 congruent to angle 2 because those are alternate interior angles. They share US in the middle, so US is congruent to US. Reflexive property. I now have enough to say those triangles are congruent. Triangle SRU is congruent to triangle UTS because I have a side, an angle, and then the side they share. I've got the side, the angle, and the side they share. So I have side, angle, side. If the triangles are congruent, then all the corresponding parts are congruent. So RS is congruent to UT, that's the top and the bottom, by CPCTC. And therefore, RSTU is a parallelogram because both opposite sides are congruent. Okay, so I'm proving all the ways that I can prove something is a parallelogram, and then you'll be able to use these ways. This is a frequent multiple choice question on the Regents exam. Okay, exercise 5 we're just going to look at quickly. So in this diagram I have AC and BD bisect each other at M, so that means that, this is congruent to this, and this is congruent to this. All right. They want me to draw in AB. Let me get a different color. They want me to connect all these points together. So I'm going to draw in AB. I'm going to draw in BC. I'm going to draw in CD. And I'm going to draw in DA. All right. Using a straight edge is ABCD a parallelogram? How can you tell? Well, let's use a ruler and we're just going to measure all these sides. So I took out my ruler and I measured all these sides. So AB is 4.2 centimeters and CD is 4.2 centimeters. And then I measured AD, which was 3.6 centimeters, and I measured BC, which is 3.6 centimeters. So AB is congruent to CD and BC is congruent to AD. And that's enough to prove that something's a parallelogram. Okay, but referring to that, we're going to prove that ABCD is a parallelogram given that its diagonals bisect each other. All right, so we just did it by measuring with a ruler, but let's actually prove it with statements and reasons. So number 1, which is saying that AC and BD bisect each other. That was the given that I started with. If they bisect each other, then that makes AM congruent to CM, and it also makes BM congruent to MD. And that's just definition bisector. I'm going to put some numbers in here. These vertical angles are all congruent to each other. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. As I said, those are vertical angles. Vertical angles are congruent to each other. That makes triangle AMB, the triangle on the top, congruent to the triangle on the bottom. Well, actually, all the triangles are congruent to each other. So CMD and triangle AMD is congruent to triangle CMB. They're all congruent to each other by side angle side. Okay, and if they're congruent to each other by side angle side, then that makes all the corresponding parts congruent. So AM is congruent to DC, and AD is congruent to BC by CPCTC. And if that's actually true, then that makes that a parallelogram, because I just showed that both opposite sides are congruent to each other. But think about what I started with. I started with the diagonals bisect each other, and that was enough to show that the opposite sides are congruent, therefore making it a parallelogram. So the reason I know it's a parallelogram, a quadrilateral with both opposite sides congruent is a parallelogram. Okay, and we'll start off tomorrow. Oh, actually I have a summary right here, but I think I'd like to look at this tomorrow with you guys, so we'll do this tomorrow. Okay, so this summary we'll do in class tomorrow.